Welcome back to our lesson practice review of chapter 1. We are now on lesson 7 that we're going to tackle today. For our summary, we are going to talk about what we did in the lesson in class. It really focused on the same idea as lesson 6, except for the fact that lesson 6 was talking about translations. Now we're talking about reflections. So we can reflect functions over the x-axis by multiplying the outputs by -1, whereas if we reflect over the y-axis, we multiply the inputs by -1. So we have this two different situations here when we see the reflection over the x-axis in the first one, reflection on the y-axis on the second one. And so we'll kind of look at what the equations look like in this lesson practice and how we're going to write those as we go forward. So to get started for number 1, we're going to select all the transformations that move f of x onto g of x. So first of all, we're talking about a reflection. We can see that f of x is going to flip over the line or the y-axis here. And so that reflection would be a reflection over the y-axis. We could also say that it's a horizontal translation here, because if we just took every point from f of x and shifted it 8 units to the left, then it would land on top of the points on g of x here. So I would say that the two different transformations could be a horizontal translation or a reflection over the y-axis. For problems 2 and 3, we're looking at a graph d of x, and we're going to sketch the transformations and what happened to them. So when we do d of -x, we are multiplying all the inputs by -1. And so if you think about it, we're multiplying the x values by -1. So that is, in this case, switching the signs of all of the x values. So when this first point here that I just highlighted in blue, that's -3. If I multiply that by -1, it becomes +3. If I take this point, if I multiply that by -1, we get +2. And so as we kind of go through here and we take these points, we kind of see that there is a reflection over the y-axis on this one, and we get a function that looks kind of like this that matches. For number 3, we have negative d of x. So you think, d of x is our y values. We're multiplying the y values or outputs by -1. That just takes, the inputs here, and then we change the y value to the negative version. So when this +1 becomes -1, this +2 becomes -2, and so on and so forth. And so we get this function that looks like that. For number 4 and 5, each graph express k of x in terms of j of x. And so in this one here, we're looking at j of x is the red function, and we are changing it into k of x. And so what we have to do to j of x is we have to reflect that over the x-axis, or change all of the y values to its negative version, right? Because if, for example, this first point here, the x value is staying the same, but I'm multiplying the y value by -1 to make it land on top of k of x. So this one here, we would write negative j of x. Whereas for this one here with k of x, it is taking the x values, let's say this one here, and we have a x value of -2. If we multiply that by -1, it becomes +2. So instead, we are now doing j of -x. And so the inputs or the x values are being multiplied by -1. Okay, for number 6, g of x is a transformation of f of x, and we are asked to describe the transformation. So couple different ways that you could kind of describe it. When I look at this here, I see that all of the outputs here are the opposite, or the other sign, or multiplied by -1. And if I was going to write the equation for that, then I would be multiplying, again, the outputs. So I would say negative f of x. For 7, the graph of c of x is shown. We're asked to sketch the transformation negative c of -x. So that means we're actually going to be multiplying the inputs and outputs by -1. So the first number I'm going to start with here, I'm going to start with the vertex of this parabola, and I'm going to multiply the input by -1, which makes it over here at -3, and then the output by -1. So the y value, which was -2, now becomes +2. I'll do that with a couple other of these points so we can kind of see here at what looks like 5, 0. I multiply the input by -1, and then the output is just 0, so that multiplied by -1 is still 0. Same with this +1, multiply that by -1, and so we can kind of get this sketch here of our parabola that looks something like this. All right, on to our spiral review for problems 8 and 9. We are asked to write the equation for t of x in terms of r of x based on the following transformations of r of x. So this one here, we're asked to take r of x and translate that left 5 units. Remember, the left and right should tell us that it's really going to be r of x. And then we're going to do something on the inside of this. Going left and right, it's really kind of the opposite of what we would expect. So that would be r of x plus 5. For number 9, we are asked to translate r of x 7 units to the right and 1 unit up. So to the right is going to be on the inside, and it's the opposite sign. And then 1 unit up would just be plus 1 on the outside of that function. So r of x minus 7 plus 1. That wraps up our Chapter 1, Lesson 7 practice. We are going to be moving on to 1.08 in a little bit here if you want to check that out.